Alright, good afternoon everyone. We're going to go ahead and talk about Chemical Foundations 1.3. Now, as we go through this, you're going to see a couple of parts that I'm actually going to have a link to another video for periodic table and for atomic structures, just to give you a little bit more background. But this is going to be a little bit more of a general overview. So as we get ready to get started, I want you to pay attention, make sure you're taking notes, and bring any questions you have into class. I would love to be able to answer them and to be able to help you out. Well, let's start. Now, our learning goals for this Chemical Foundations 1.3 is going to be, I can understand what a natural law is and give examples of where it is applied, and I can distinguish between different types of matter and justify the method of separation. Now, as far as the types of matter, we're going to go, we're going to go through this a little bit more tomorrow, but you want to look back at what are the things that you saw in the activity we started in class. Now, I just thought this was a little funny. Law of gravity is strictly enforced. Now, as we deal with scientific laws, many times these are going to be things that are observed on a regular basis, every day, and they are the what that happens. Remember, we said a theory is going to be the trial at why, but the actual law is going to be the what. Now, here are a couple of examples that we're going to utilize a lot. First is going to be the law of conservation of mass, which basically just says matter cannot be created or destroyed in a chemical reaction. What we start with will always be what we end with. Now, what about the law of definite proportions? A given compound will always contain exactly the same proportion of elements by mass. What does that mean? If I'm looking here, if I'm writing and I have sodium chloride, every single formula unit that I have of sodium chloride will be composed of the same amount of material, the same mass of sodium, the same mass of chlorine. Now, law of multiple proportions. This one's a little bit different, but basically the idea is if I have two different elements that I'm joining together to make various compounds, in the case what we have here with nitrogen and oxygen, each time I do utilize this, I'll be able to reduce it to a whole number ratio. That's the general idea we're going to look at. So if I have nitrogen with oxygen, it's going to be a 1-to-1. If I have 2 oxygen to go with 1 nitrogen, again, it's a 1-to-2 ratio, and so forth. But we can always get it down to a whole number or a set of whole number ratio. Oops, sorry, marked through it. But you get the idea. Now, in terms of types of matter, we want to take a little bit of time and look at the different types of mixtures. Now, in the activity you guys we're covering today, we only talked about mixtures in general, but it really breaks down into 2 categories. The first is going to be what we call a homogeneous mixture, or homogeneous mixture, which is going to contain a uniform matter. Now, look at the examples of what we have here. I have Kool-Aid, a piece of steel, as well as this frosty drink, which actually looks pretty good right now. Now, if I look at each of these, I can't tell where the mixture of materials, one stops and one starts. Because this is the case, this is what we would call a homogeneous mixture, a homogeneous mixture. Now, on the other side, we have what's called a heterogeneous mixture. These are going to be the mixtures where we can tell the different parts. Given the example of oil and water in the top right hand corner, or even looking at salads or this mixture of beans and rice, we're able to pick out, and we literally could take our time and pick out each individual bean, each individual rice grain. These are going to be heterogeneous mixtures. Again, keep in mind, homogeneous, homo, same, heterogeneous, hetero mean different or opposite. So keep these in mind as we talk about the different mixtures. Now, when we talk about pure substances, we run into 2 main categories. That's going to be elements, which we have this lovely table right here behind me, 118 of them, which is going to be the simplest unit of matter we can use that's going to retain all the properties. And then we have the compounds, which are usually going to be a substance made up of 2 or more elements. Now, some of you will probably ask the question, okay, so what's the difference between a compound and a molecule? Big thing here is not all compounds are molecules, but all molecules are compounds. I'll explain that one if you're still a little lost on it tomorrow in class. Now, this is a little, I guess, decision flow chart if you were to to fill in the information. Looking at it, does the composition vary? Does it change? If the answer is no, then we're going to run towards pure substances. If it's yes, we're going to move towards our mixtures. From there, we can begin to distinguish a couple of things. One, with our mixtures here, one of the things I want you to note that they can be separated by physical means. So, physically separated. Now, what about our pure substances? You notice that it only points out chemical methods. Only by chemical methods can we separate out our compounds, and even the elements, we can't really even go further than that. And we'll talk again about that a little bit later. Now, what about how we separate? The main three ways that we'll talk about are distillation, filtration, and chromatography. Filtration is one that I believe most people will be familiar with. If I have, a solid that's sitting in the liquid, I may get some filter paper or a coffee filter, those types of things, so that the solid stays in one location and the liquid is able to run through. But the two other ones that are going to be brand new are distillation, which is basically we're going to look at how to vaporize one substance while the other remains based on the different physical properties. And chromatography, which we're going to use, we actually have a lab coming up where we're actually going to get a chance to do a slight chromatography. But again, separating out these solutions using the different densities and other properties. Now, this one I call 1.3b, mainly because it's a side topic off of the organization of matter. We're going to talk a little bit more about the elements. Now, I'm also going to include a link, and it's probably going to come up right here on your screen, right over here to the side on your screen, so you'll be able to access it. But this is going to be talking about the periodic table. I'll do the same thing a little bit later as we talk about atomic structure. Now, basics, some key overview points. One is going to be developed, the first accepted periodic table is developed by Dmitry Mendeleev, organized by increasing atomic mass. And one of the things that he did is, as he looked at the known elements at that time, he left some spaces because he figured that there are some elements that would probably fit into those areas. Later on, we were actually able to find many of those. But along with organizing them by atomic mass, there are also some different characteristics we'll talk about. And some of those we'll talk about a little bit later on as we talk about periodicity and periodic trends. Now, our modern periodic table, as you can see, is going to be composed of mainly metals. So if I'm looking over here, all the way up until I get to this point here, basically. Oops, ran out of space, sorry. Sorry, guys. But basically until I get to that brick line, all the way back, that's going to be my metals. Now, the upper right-hand corner is going to be our nonmetals. Our groups, sorry, our rows going across are going to be our periods, and our columns are going to be our groups. These groups, these numbers at the top for our groups, are going to be very important in terms of determining how many valence electrons, how the bonding will happen, and so forth. Now, a couple of quick points about metals. Many of these you already know. Some of the terms might be new. Metals are going to be malleable, which means they can be pounded into sheets, shiny, ductile, good conductors of heat and electricity. Whereas nonmetals are basically the opposite. Soft, brittle, dull, and usually very poor conductors of electricity. This is a little acronym that we're going to use in order to remember the names of the groups. With remembering the names, it'll also go back to the properties. Again, go back to that video on the periodic table so you can actually see how things are going to work in terms of what are some of the properties of these families. But just remember, Al always eats tacos by Cindy's New Orange History Notebook. Sounds like a very weird statement, but it's okay. Just bear with me. Now, this is where we're going to end this video. I'm also going to add a link to the structure of the atom so you can get an idea and see how to work within just the structure of the atom setup. If you have any questions, please write them down. I'll be happy to answer them in class. We're going to take a couple days to get through this, so don't worry, don't fret. If it seems like we're moving pretty quick, just feel free to stop me and say, Mr. Baldwin, can you explain? Have a great evening. I can't wait to see you guys in class, and have a great day.